Hey there, students. On this clip, we're going to be going over some examples on simplifying exponents using the properties of exponents. Okay, so let's take a look at question number 1. So we are to find which radical expression matches this exponential expression right here. So if you take a look at this, this is a situation where you apply the power of a power property of exponents. Remember what that is, right? If we have x to the a raised to the b power, you have a power of a power, you're going to multiply the powers and you're going to have x to the ab. So that's exactly what we're going to do here. But the situation here is that the power on the outside is a fraction and this is not a fraction. So to rectify that difference, we can just express 17 as a fraction, as 17 over 1. Okay, so we'll multiply, we'll apply the power of a power property. This is going to be x to the 17 over 1 multiplied by 9 over 7. Okay, if you multiply the powers, you're going to have x to the 9 times 17 is 163 plus 90, which is 153 over 7. Now we're going to apply the fractional exponent property to this situation right here. The denominator is a root and the numerator is a power. So we can express this term as the 7th root of x to the 153. Alright, we can clearly see that our answer is option letter C. Alright, let's take a look at number 3. We have to find the 11th root of 10 x to the 8th y to the 6th. You have to express it as rational exponents. So in this case, what we're going to do is express this as 10 x to the 8th y to the 6th raised to the, now we apply the nth root property of exponents. We're going to raise this entire expression to the 1 over 11. Okay, so here you have a power of a product of powers situation here. So what we're going to do is distribute this power to these respective powers. 10 doesn't have a power, so the default power is going to be 1. Okay, so we're going to distribute 1 over 11 to 6, 8, and 1. Our result is going to be 10 to the 1, 11, x to the 8, 11, y to the 6 over 11. All right, and the correct answer for this is going to be option letter B. All right, let's move on to the next problem, problem 5. Now this is a power of power situation again, but in this case we have fractional powers, okay? So if we apply the power of power property to this term right here, what we're going to do is just simply multiply the powers, okay? So we're going to have 3 over 4 multiplied by 7 over 8. Okay, if you multiply the powers, you're going to have y to the 3 times 7, 21, divided by 4 times 8, which is 32. So our final result is going to be y to the 21 over 32. Option letter A. Alright, let's take a look at question number 7. In this example, we have a quotient of powers, two powers being divided by each other, which can be expressed as a quotient of powers. So what's the quotient of powers property? If you remember what it is, we have x to the a over x to the b. The answer is going to be x to the numerator, the power of the numerator minus the power of the denominator, x to the a minus b. So the quotient property of exponents states that if you're dividing two exponents with the same base, you subtract the powers. Alright? That's the situation we have here. The bases are the same, so we're going to have to subtract the powers. So this is going to be b raised to the 2/3 minus 1/7. Alright? Okay, now how do we resolve this difference of fractions in the numerator? Let's find the LCD. The LCD of 3 and 7 is 21. Alright, so to make this into 21, I have to multiply the numerator and denominator by 3. Then over here, I'll multiply by 7. Okay, and then we're going to have b to the 14 over 3 minus 3 over 21. The first denominator is 14 over 21 also. Okay, 7 times 3 is 21. Alright, now the denominator is identical. We subtract the numerators, we're going to have b to the 11 over 21. Final answer for number 7 is option letter A. Okay, an example of applying the quotient of powers property. Alright, let's take a look at number 9. We're going to find the fourth root of 49. Going to express the simplified form in radical formulation. So let's go ahead and do that. So first thing I'm going to do is apply the nth root property and express this as 49 to the fourth power. Okay, now can I express 49 as a power? Well, let's see, can I find factors to 49 or express 49 as a product of prime exponents? The answer is yes. What goes into 49? 7 goes into 49 7 times. So 49 as a product of prime exponents is 7 to the second power. So what I'm going to do now is replace this 49 by 7. So this is going to be 7 to the second power raised to the fourth power. Alright, so what property of exponents are we going to apply here? We're going to apply the power of a power property. Remember the rule of a power of a power, you just basically multiply the powers. And then before I do that, oh yeah, also using if I use the nth root property, this ought to be a fourth, 1 over 4. And this ought to be 1 over 4. Okay? Because the nth root property, we have the nth root of x. That's the same thing as x to the 1 over n. That's the nth root property of exponents, not 4. Okay, so we have it like that. So what we're going to do is simply multiply the exponents. We're going to have 7 raised to the 2 over 1 times 4 over 1. 2 over 1 times 1 over 4. And when you multiply that, you're going to have 7 to the 2/4, which is 7 to the 1/2. Okay? That's what you get when you apply the power of a power property to the to this expression right here. Okay, so how can I express 7 to the 1/2 power as a radical? We're going to use the special case of the nth root property. Okay, so the special case of the nth root property is the square root. Alright, so 7 to the 1/2 power is square root of 7. As you can see, our final answer is option letter A. Alright, so there you have it. Alright, let's take a look at question number 11. We have to find the fourth root of the square root of 1296. So in order to do this, first thing we're going to do is we're going to rewrite the radicals as fractional exponents. All right. So how do we go about doing that? Well, let's start with the outermost one using the nth root property of exponents. The fourth root of the square root of 1296 is the square root of 1296 raised to the 1/4 power. Okay. Now, if I apply the nth root property to the square root of 1296, we're going to apply the special case of the nth root property. So that will be 1296 raised to the 1/2 power. And then we raise the entire thing to the 1/4 power. Okay? So now, what property am I going to use to resolve these situation right here? Well, we have a power raised to a power, so we're going to use the power of power property, which tells us that we just simply multiply the powers if you have a power raised to a power. So this is going to be 1296 raised to the 1/8 power. Alright, so there you have it. Alright, so to finish this off, to have it match with one of our options right here, we're going to have to express 1296 as a product of prime exponents. Alright, so let's take 1296 and we're going to break it down. I can look at my options here. It looks like we can try 6 as a candidate. See if that works, because 6 of course multiple times here. So if I take out 6 from 1296, I'll get 6 times 6 goes here twice, 6 goes in a 9, 1, and then a 36, 6. Alright, let's try 6 go in here again. 6 goes into 2, 16, 3 times. Remainder 3, 36, 6. 6 goes into 36, 6 times. Alright, so basically 1296 is 6 to the 4th power. So we can do replace 1296 with a 6 to the 4th power. So this becomes 6 to the 4th power raised to the 1/8. Now we're going to apply the power property again, and that will yield 6 to the 4 over 8. You divide 4 by 8, you're going to have 6 to the 1/2. And that can be expressed using the reverse of the special case of the nth property. This would be the square root of 6. And our final answer is option letter A. Alright, so let's take a look at question 13. We have to simplify 8 to the 4/3 power. Now let's see. There are two ways you can do this. First way you can do this is by finding the cube root of 8 and then finding the 4th power of the cube root of 8. Or another way you can do this is you express 8 as a power of prime exponents, and then we simplify. Okay, so let's do the first way. How about we find the cube root of 8 and then raise our answer to the 4th power. If we did that, the cube root of 8 is 2. And then we raise 2 to the 4th power. That's the same thing as 4 times 4. And the answer is clearly number 16. Okay? That's one way of doing it. If I wanted to do it another way, method 2, the second method I stated earlier is you express 8 as a power of prime exponents. So 2 goes in 8 4 times, and then 2 goes in 4 twice. So 8 is 2 to the 3rd. So basically this will become 8 to the 4/3 will become 2 to the 3rd, and that raised to the 4/3 power. And then here we'll use the power property, and this becomes 2 to the 12 over 3, which is 2 to the 4th. And then 2 to the 4th in expanded form is 16, as we found earlier. So we can clearly see that our initial answer is correct. Okay, so whichever method you like to use, as long as you get the correct final result, which is 16. All right, let's take a look at question 15. We have 81 raised to the negative 1/4 power. In this case, we're going to be using the nth root property and also the reciprocal property of exponents. Okay, so remember what the reciprocal property of exponent is if you have a negative exponent, you have to reciprocate the term with the negative exponent. Okay, so 81 raised to the negative 1/4 is equal to 1 over 81 to the positive 1/4. Now what we're going to do next is break down 81 and express it as a product of prime exponents. So 81, we can take out 3. 3 goes into 81. 3 goes into 8 twice. 21, 7. 3 goes into 27 9 times. And then 3 goes into 9 3 times. So 81 is basically 3 to the 4th power. Alright? So let's make the substitution here. We're going to have 1 over, instead of 81, we'll replace that with 3 to the 4th, and then to the 1/4. Now you have a power situation, so you multiply the exponents, and then you're going to have 1 over 3 to the 4/4, which reduces to 1. So it's 1 over 3. That will be a final answer, which is option letter D. Okay, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. Please post a comment to let me know what you think about this clip. More clips can be found on mygotserve.com. Thanks again for watching and have a wonderful day.